All right, welcome to the July 2021 Springfield AWS User Group. Tonight we're going to talk about introduction to the AWS command line interface and the AWS SDK, specifically how to get started using the command line and dev tools to manage your AWS resources. A little bit about Springfield AWS. We're based in Springfield, Missouri. You can find us on Meetup at meetup.com/SGF AWS, on YouTube at /SGF AWS, and on Discord at sgf.dev. We're part of the greater Springfield Dev Collective, and you can chat with other group members in the #AWS channel in our Discord group tonight. A little bit about me. I have a little over 20 years of experience managing IT and working in software development. I've been using AWS for over 8 years. We started out by using AWS as more of a disaster recovery backup plan. We're storing files there. Eventually, Forklift moved some of our Linux servers over to AWS EC2 instances. And then really benefited from that and saw the potential for using the native AWS services within our platform. And so with that, I've been using CLI tools and APIs to manage various hosting infrastructure for almost 2 decades. And of course, using those tools to manage AWS the last 8 years. Here's today's agenda. We'll start off with some terminology so that you understand what we're talking about and what we will cover and what we won't cover when it comes to managing your AWS resources. And then we'll dive into some CLI specific benefits and examples, and then some SDK benefits and examples, and then we'll wind up with some resources. We'll actually cover resources specific to the CLI examples I give and to the SDK examples. So terminology. Of course, anyone who's gotten started with AWS or is in that world knows that there's a lot to it. If you're just getting started and not sure where to begin, you can sometimes get overwhelmed. So here are a number of the different ways people manage their AWS resources. Number one, the web console. Everyone gets their start there. It's made to be accessible to everyone, but it's not always the most efficient way of going about managing things, especially if you're building out large environments or needing to rebuild similar environments over and over and over, or you need to integrate AWS into your application or your daily workflow. That's where other tools like CloudFormation come into play. You can build out a CloudFormation template. We'll show a very basic example of that today in our CLI demonstration. And that basically defines your infrastructure as code. We're not going to dive deep into that today. The AWS API is sort of the direct integration with AWS. They have a raw REST API that all of these tools we're talking about today interact with. It basically gives you direct access to your AWS resources, but it's a lot more challenging to use than the CLI tools that we're going to talk about today, or the SDK tools that have been basically built to work in harmony with whatever programming language you're used to using. There are also a couple other things worth mentioning here. The SAM CLI is something we will not be covering today. That is a CLI that's specific to the serverless application model, or think of your Lambda code that might run in their serverless environment. Like I said, we will not talk about that today. We might cover that in a future topic. And then finally, the AWS CDK, or Cloud Development Kit. That's a more of a high-level tool that you can use to build out your cloud infrastructure. Again, something we won't be talking about today, but something to be aware of. as you're looking to familiarize yourself with the available tools that AWS has to offer. So, like I said, we'll be focusing on the API and the CLI that are highlighted on screen. So let's start off with the command line interface. Benefits of the CLI are specifically the ability to control your AWS services and resources through the command line. So if you're familiar with the command line, this is a great thing to have in your toolbox. You can automate infrastructure changes and management through local scripts. It's much faster than using the AWS Web Console, especially if you're needing to do the same things over and over. Day to day, I reach for the AWS CLI if I want to go and just pull up a list of maybe S3 buckets, or dive into a bucket and look to see what kind of files are sitting in there, if it's not a large bucket or a deep bucket in terms of folder structure. Also very handy if I'm wanting to get a list of EC2 instances that are running. But I can do that very quickly from the command line interface. I don't have to pull up the AWS Web Console and then log in again, since it tends to log me out about every day. The CLI is always ready to go. CLI features. So mentioned that AWS has many different services. The CLI does a great job of keeping up with that. As of right now, with the AWS CLI version 2.2, there are about 267 top-level commands representing nearly every AWS service that's available. I listed all of those on the screen, just pulled them out of the help for the current CLI tools. Some AWS reference materials from a prior reInvent that was announcing the latest CLI tools said that there were over 6,000 total commands, over 37,000 total parameters available. So very flexible. I highlighted the tools we'll be covering in here today. Can barely see them just because there are so many, but we'll specifically talk about AWS Configure, AWS EC2, AWS S3, and I didn't highlight it, but AWS CloudFormation. Let's see. CLI Prerequisites. If you aren't familiar with this AWS CLI, you are going to want to have some command line basics under your belt before you get started. We'll not be covering a lot of command line basics today. You're going to need to know how to use IAM, or Identity and Access Management, to create a user. I'll provide some basic instructions, but we're not going to dive deep into that today. You'll need to know how to use AWS S3, at least the basic concepts, what it means to create a bucket, what it means to upload or download objects. And then finally, of course, if you're going to use the CLI, you need to download it. The version 2 is available for Linux, Mac, and Windows. I listed the URL here. So before we do anything with the CLI tools, we need to be able to authenticate to our AWS account. AWS, when they receive a command from our Mac or PC, they need to know who we are. They need to know which account we're wanting to interact with. And then, most importantly, they need to know exactly what we are allowed to do once we act on that account. So, like I said, I'm not going to go deep into how to do this on IAM, but the gist of it is you're going to want to log into the AWS Web Console and go to the IAM service. You're going to want to create a user group with policies for the purpose of this demo. These are the things that I did. I created a user group with policies Amazon EC2 full access, Amazon S3 full access, and AWS CloudFormation full access. Now, after everything's said and done, if you're working in a sandbox account that's only used for this demo or walkthrough, great, you can delete the account when you're done. But if you're following along, within an account that you use for other things, just be sure to remove this group and the user after you're done, because it does give you full access to any of the EC2 instances in your account, any of the S3 buckets in your account, and any of the CloudFormation stacks in your account. So not something you'd want to leave around. But for the sake of this demo, very easy way to get up and running. And then you'd create a user with programmatic access, and you would associate that user with the user group you just created. Finally, after you've gone through those steps, AWS will list a access key ID and a secret access key that you need to either download or record for the next steps here. That pair of keys is what will allow your command line tool or even your SDK to interact with your AWS account. And in this case, when the command line does interact with AWS, AWS knows that assuming you followed these steps, that command line tool can access any EC2 resources on your account, any S3 resources on your account, and any CloudFormation resources on your account, but cannot access anything else on your account. You can always go into IAM and really fine-tune those permissions. Normally when we're doing this, we will only give the permissions that are absolutely necessary. That's considered least privilege, but for example, we may only say allow this IAM user to list buckets and upload files, or list buckets and list files and to download objects, but no more. So that maybe a user couldn't delete a bucket, a user couldn't delete a version of an object, so on and so forth. So once you've created that IAM user, we need to configure your AWS command line tools to use those credentials. Now, if you're first getting started and you only have one AWS account, this may feel like overkill, but I highly recommend that you use a named profile when you're interacting with AWS CLI. By using named profiles, you can store credentials for multiple IAM users, even across multiple accounts in AWS, and switch back and forth between those very easily. And I'll point that out in the screenshots here. But the gist of it is you choose a profile name, and for today, I chose the name Demo, keeping it simple. I checked to make sure that profile isn't already in use, and I've got a screenshot here that shows that I ran AWS configure list, and then I used the parameter -- profile space demo. And by doing that, it tells AWS to run configure list with the saved credentials for demo. And it runs that. It checks to see if there are any credentials for that profile, and there are not. So then I go and I run AWS configure with the parameter profile demo, and it prompts me for that access key ID and the secret access key that we just received from IAM when we created our new user. And in my case, I'm building everything out in region US East 1, so I specified that region, but if you're in another region, specify the appropriate region. And then I accepted the default output format. No, I take that back. I specified JSON, and then I ran AWS configure list one more time with the parameter profile demo, and this time you can see where it shows your access key and secret key and region and where all of this is stored in your home directory under .aws/config. Now, as your AWS infrastructure grows and you need access to different accounts and you add different profiles and set up different IAM users, you can take a peek at that .aws/config file or the other files in your .aws folder in your home directory, and you'll see that all of those different profiles are stored in a single file. So now that we've created a profile, we've configured that profile named demo, what I like to do is set an AWS profile variable to that current profile name. So in this case, I'm on a Mac and I use the command export AWS profile equals demo. And then at that point, I can run any of these AWS CLI commands without the profile parameter, and it understands that I'm wanting to use that demo profile, which is great. So for example, I ran AWS configure list without the profile parameter, but it still showed me the demo profile with all of the access key, secret key, region parameters that we had just plugged in for that profile. And so moving forward, I'm going to run AWS CLI commands in these demos without the profile parameter, and I'll assume that you've set up a named profile, or if you really are only planning to ever have one profile, you could set that as your default profile and not worry about named profiles at all. But in the resources section, I link to a page that talks all about named profiles. Again, I can't recommend that more highly. It's just an invaluable way to flip-flop between all of our different accounts, production and testing and dev and different things like that. So I wanted to give you some practical examples in terms of what using the CLI tools might look like, just to give you an idea of what's possible. Again, with nearly 300 different services accessible through the command line tools, it's impossible in 30 or 45 minutes to cover everything. So we're going to focus today on S3, EC2, and CloudFormation. And with S3, in this particular example, I'm making a bucket. That's the AWS S3 MB command, and I specify an S3 URL. So it starts off with the protocol S3, then // and then a bucket name. Press enter. I get a response that says make bucket SGF AWS CLI SDK, which is the sample bucket we made. Now, if you're not familiar with AWS, or S3, I'm not going to deep dive, but I do want to mention the bucket name must be unique globally. So chances are somebody else in the world has used a bucket named example or demo or something like that. So I like to prefix my buckets with some keyword or name for whatever account we're using. In this case, I'm logged into an account for our SGF AWS user group. So I prefix my bucket names with SGF AWS. Not trying to make the bucket names complicated, just don't want to have problems coming up with a unique bucket name. And then after I've made that bucket, I can list the bucket contents by typing AWS S3 ls for list, much like the ls command on a normal Unix, Linux, Mac command line. And nothing's returned, but you can see on the far right that as I'm typing an AWS command, my terminal is automatically showing me the profile name, and it recognizes it as an AWS command. That's something special I'm doing using Z-Shell and my Z-Shell and Power Level 10K. I listed links at the bottom of this screen for anybody that's interested in that. I imagine that'll raise questions, so I wanted to address that early on. But I list the files in the bucket. Obviously, there's nothing there because I just created the bucket. I'll display the contents of a local file called hello.txt, which contains hello world. And then I copy that file up to the bucket. And so you can see, if you're familiar with the command line, I'm running S3 copy, and then hello, and then I'm providing an S3 URL, which includes the bucket name and the file name. And it confirms the upload by outputting upload, and then the local path, and then the remote path, and then that returns OK. And then I list the bucket contents again using AWS S3 ls, and then the bucket URL, and now it does show one file that was created at the time of this demo, and it includes the file upload time, the file size, the file name. And now I'd like to copy that file. I'd like to copy a file from S3 to my local computer. Also easy to do with the command line tools. So we just run the reverse, AWS S3 copy, or CP, but this time I specify the remote path first. So the S3 URL with the entire key name, or in this case file name, hello.txt, and I'd like to copy that to a different file locally just so that we can see that this is indeed working. So I'm copying it to local.txt. I get a confirmation, it's downloading to local.txt, I get an OK status, and now I'm going to output the contents of local.txt, and sure enough, the same content, hello world. So at this point I'm going to clean up after myself. I'm going to remove that file, so AWS S3 RM, and then finally I'm going to remove the bucket, AWS S3 RB, and then the URL to the bucket. Keep in mind, if you're going to remove a bucket, it has to be empty. So the command line tools are great for automating some of these things, especially if you need to delete a lot of files or a lot of versions. You're welcome to ping me if you'd like an example in the near future. There are plenty of resources online, but we recently needed to delete a lot of versions of a lot of files before we could remove a bucket, and the command line tools made that a breeze. So let's move on to EC2 management. Much like S3, I wanted to sprinkle in a couple different services here so you can see how there are similarities and how there are some differences. The output of some of these commands can be very verbose. That's probably the biggest takeaway with this EC2 example. So in the screenshot, I'm have bullets here describing what's happening, but I'm describing the instances in this particular AWS account. And then I'm describing the instance status, for example, whether it's running or not. And then I'm starting an instance. And in the first example, I run AWS EC2 describe instances. And if I were to only run that, I would get pages and pages of output because of all of the JSON output that Amazon provides to me, which can be great. But for what we're doing right now is certainly overkill. It makes it hard to really see, okay, I have two instances and this is where they're located. This is their instant type. So I'd like to introduce you to a command called JQ, or JSON query. I'll link to that command in the resources section in a moment, but if I were to run AWS EC2 describe instances and pipe that to JQ alone without any parameters, that by itself pretties up your JSON output. It color codes it, can sometimes reformat it if there is an issue with the default AWS formatting, but it definitely makes it easier to read. So at a minimum, I'd highly recommend installing JQ and just piping your output to that if you're needing to parse something visually, because it makes it so much easier to look at. But in this case, I gave you an example of a query that I can run. I'm looping through the reservations and then the instances, and then I'm outputting the instance type, the instance ID, the instance type, and the availability zone. I apologize, that's cut off. I'll include a GitHub link and make sure to post these examples out in GitHub in the next day or so. And then finally, in this last piece, I'm querying availability zone, but if you look at the raw JSON output, you'll see that is actually in a that output is nested, and so I'm having to use special syntax for that particular item. But most of the time, if the tag that you're looking for is not nested, you don't need to list two parameters for the tag. It's a nice handy shortcut that they offer. And so by running that query, I can see that that this account has two EC2 instances running. One of them is a T2 micro instance in US East 1C. One is a T4G nano instance, a Graviton or ARM instance in US East 1D. And I'd like to know if those instances are both running. So I'm running another AWS CLI command, AWS EC2 describe instance status. Since I'm not providing any other parameters, it will list the status of all instances, piping that to JQ, and then this particular query, excuse me, and then this particular query loops through instance statuses and outputs the instance ID and the instance state. Now you'll notice only one instance is running. If an instance is stopped, it is not output by this command by default. Excuse me. And so I'd like to start the instance that is not running. Excuse me. Sorry about that. So I'm going to run AWS EC2 start instances with a parameter of instance IDs and the ID that is not running, which is this one right here. If I wanted to start a bunch of instances, I could list them with an instance ID, a space, another instance ID, another space. It's a space delimited list of instance IDs. All right. So that's a very basic example of how you can use the CLI tools to interact with EC2, but I like this example because it introduces you to JQ and how handy that can be when you're working at the command line. And finally, we're going to go through a quick CloudFormation example. So again, these code samples will make it out on GitHub, but we're going to start by creating a very basic CloudFormation template. We'll name it s3.yaml. We're going to create a bucket with this name, SGF AWS, prefix, like I mentioned before, -demo, -CLI, -CF, telling me that it's a demo for the CLI and CloudFormation. I'm wanting to make sure the access control is set to private. These are all related to the access control. I absolutely want to make sure that this bucket is not public. I'm going to encrypt everything in the bucket by default, enable versioning by default, and then this got cut off, but I'm going to output the bucket name. So we create this template, and then we create the stack using our AWS command line tools. So we'll run AWS CloudFormation create stack, which another benefit of my shell setup is that I have autocomplete when I'm running through this. I don't need to run AWS help and look to see what the commands are, and AWS CloudFormation help and look to see what the parameters are. You can literally type AWS Cloud tab and it'll either complete it or show me my options thanks to a plugin for Z shell. So I've done that. Create stack. I provide a stack name, which this I believe needs to be unique to your account. I don't know that it needs to be unique across accounts, but I could be wrong there. Nonetheless, I prefix it with SGF AWS, just like the bucket names, to be safe. And then a template body, which in this case will be this S3 YAML file that we just created, the CloudFormation template that I just showed you. And you can specify that with a file URL, so file : //./s3.yaml. And then that begins building the stack. If we had a huge CloudFormation stack, we'd probably give it some time and check back. But this stack is so simple that we were able to check it right away. And you can see that we ran this command 25 seconds after the minute, and then I went and ran AWS CloudFormation describe stacks, again with stack name and the stack name that we just created, piped that to JQ to color code it, and you can see that 34 seconds after the minute, or 9 seconds later, it had finished creating the stack. And I didn't show all of the output, but the gist of it, just like any CloudFormation stack, is that it shows the basic information, the stack name and description and creation time, and then further down it'll show the outputs that you specified in your CloudFormation template. So it shows the output key of S3 bucket and then output value of the bucket name and so on. So we were able to create the stack, describe the stack, and then finally we'll delete the stack. So I ran AWS S3 ls to list the files in that bucket and confirm that it was empty, and it was, because if you were to delete this stack that had created an S3 bucket and the bucket had files in it, when you go to delete the stack, it will try to delete the bucket, but it's not going to try to empty the bucket. So the stack delete will fail. So just to save myself the headache, I made sure that I hadn't created any files in that bucket. Ran AWS CloudFormation delete stack, specified the stack name, accepted it right away, waited a few seconds, ran the same thing that we ran before to describe the stacks, AWS CloudFormation describe stacks with the stack name, piped it to JQ just because it's a habit, and then it said that stack no longer exists. So we're done. That's the very short life cycle of a very simple CloudFormation stack, but hopefully it shows you what's possible with the command line tools. And with that being said, here are a number of resources specific to what we covered today in the CLI section before we move on to the SDK section. The AWS provides a great official download and reference page for the command line interface listed here. I wanted to be sure to link directly to the named profile reference that I was talking about. That describes how you can manage named profiles on Linux, Mac, and Windows. So if you're not on Mac and you need to look up how you might use that on your platform, that page would be your go-to. I also wanted to list a link to JQ. That provides more information about JQ. You would normally, at least in my case, I believe I installed the JQ through Brew on Mac. They have a number of different ways to install it, but you can find that there. You can also find how to build queries on their website. And then we didn't cover this today, but I wanted to mention it. It definitely deserves mentioning. As someone who's used the command line tools quite a bit, one thing that I feel is lacking with AWS command line tools that is filled elsewhere is the S3 syncing features. So if you have a local folder full of many files and you have a bucket that you'd like to keep in sync with that folder, AWS command line does offer some sync features, and I know that they've improved them, so maybe they're up to par now, but I've been in the habit for years of using s3tools.org, the Amazon S3 tools that they provide. Specifically, they have a command called s3cmd space sync that we use if we're needing to move files around for some reason, either from a local computer or a server to a bucket or vice versa. And the situation is more complex than just a one-time copy. Like keeping things in sync and making sure that sizes and timeframes and things like that are checked. But I'm not going to talk much more about that, other than if you do have a need to keep files in sync between devices for some reason and you're not able to do what you'd like to do with the native AWS command line tools, that might be worth a look. And finally, a link to the GitHub where I'll be posting these command line examples. All right, so with that, we're going to switch over to the SDK. I'm not going to dive into quite as many SDK examples, but I do want to talk about what's available and why you would use it and when you would reach for that versus dropping to a shell in PHP or some other programming language and just running an AWS CLI command. The SDK is a much better approach, but if people aren't aware that it exists or aren't familiar with it, I could see where if they already had the command line tools set up and running, they might reach for them by default. So Highly suggest if you are developing software and you need for your application to interact with AWS in any way, that you reach for the SDK for your language. Some of the benefits of the SDKs are the ability to natively control AWS services from within your application, again, without reaching for the CLI or dropping to a shell to run a CLI. It's just an unnecessary risk, in my opinion, and also just not the right approach to use the CLI tools from your application, unless your application is written in Bash, I suppose. It allows you to automate infrastructure through your application. I mean, in our case, some of our service checks and scaling and things like that for our platform are performed from native jobs within our Laravel application. And I don't think that we would be able to do nearly as much, nearly as quickly, and nearly as efficiently without reaching for the SDK. And finally, much like the CLI, it's very faster and more efficient to use the SDK than to use the AWS Web Console. So even for some basic tasks, we find ourselves building out UIs in our application just so that we're not having to go to the console to scale something up or down. If we know that we are maybe going to process a bunch of extra jobs, we have a control panel we can use within our application to bump up things ahead of time and scale up so that we can dump those thousands and thousands of jobs to be processed and not have to wait 4 hours when we can scale up 4x and be done in an hour or less. So it's great for all of that. But AWS will tell you it's the best way to access and manage your AWS services with your preferred development environment. So some features that really make the SDK worthwhile. Like I just said, you can access and manage the AWS services with your preferred development language or platform, assuming that it's supported. Many are. I mean, if you're using something cutting edge or something super old, you might be in trouble. But I've listed a screenshot of some of the many platforms or libraries and languages that are currently supported. Of course, JavaScript and Python and PHP and .NET are. This screenshot only covers some of them. They listed other miscellaneous things, so don't assume that this is all that they cover. But as far as features, you could interact directly with AWS REST API. I mean, and sometimes you'll get into a situation where you're wanting to do something and you realize that it's possible by looking at the docs, but you just can't figure out how to do that through the CLI or the SDK. And early on, I mean, we're talking 5+ years ago, I've had cases where I would look at the SDK and then I would figure out how to send those raw SDK or API, and I'd figure out how to send the raw API parameters as options in the SDK because the SDK just didn't support them natively. So it's good to be aware of the REST API, but it sure is nice to not have to work with it directly. The documentation on the API isn't quite as nice as the documentation on the SDKs, and of course the SDK is basically converted the REST API language into your application language, so it feels a lot more natural, a lot easier to use, a lot more intuitive. And then they've built in features that you don't have to engineer on your own, such as asynchronous requests, as well as retries, timeouts, paginators, etc. So just not worth it to go directly to the REST API if you have the access to an SDK. Again, unless you're needing to reach out and find a way to use some specific feature that the API exposes that the SDK doesn't currently support. And again, if that's the case, you can almost certainly figure out what that syntax is and send it through the SDK as an option to the API without having to interact with the API directly. So if you're getting started with the SDK, I'd highly recommend having some programming basics, some basic understanding of programming, and then these others are repeats. For this particular example, if you're going to need to have some understanding of IAM. So if you skipped ahead, be sure to go back and look at the IAM slides at the beginning of the CLI demo. Then you're going to have some understanding of what AWS S3 is, how to create a bucket, how to upload files, so that you understand what you're seeing in the demo. And finally, in our case, this demo uses PHP. Again, we're a Laravel shop. I'm not using the Laravel specific syntax. I'm using the actual AWS SDK for PHP. It's currently at version 3 of the SDK, found at the link shown here. So I'm not going to go through this again. I included it for sake of completeness, but we're going to make sure that we have an AWS IAM user. In the demo, I used the exact same user we had created before for the CLI demo. I show you the same screenshots of creating the named profile, because in this particular case, the SDK, if you're running the code locally, can read that profile variable name. An important note here is, I'm getting ahead of myself. We'll skip past the profile names. When we get to the code sample, and I'm going to just jump to it here, this talks about the steps of what we're going to cover. And one of them is installing the SDK, creating the script, and running the script. Let's look at that script and talk about that important note. Here's the script that we're running. This PHP script, we'll just go through it line by line, but the important thing I want to point out here is that your credentials are not in the PHP code. That should hold true with whatever language you're using. You should never put your AWS keys in your code, if at all possible. There's really no reason for it, and even if you're pushing your code to some private repository, it's just considered bad practice to commit code to repos that has these keys, and to keep your keys in the code. We basically keep our keys in environment variables, and our code is able to pick up on that. So that was the important note I wanted to mention. Let's go through this code sample line by line. Since we installed the PHP SDK with the PHP package manager called Composer, we can benefit from Composer's autoloading, and so we require vendor autoload, and it takes care of loading anything that Composer package manager has installed, which in this case is just the AWS SDK for PHP. And then we specify what we want to pull in to our project here, and this is a very simple example, but it should give you an idea of what's possible. We pulled in the AWS S3 client, AWS exception handler, and then we create a new AWS S3 client. When you're looking at the docs, it's going to mention, here's how you can pass in your access key and your secret key. Don't do it. This works perfectly without it. You've got a couple different avenues. Our production code relies on AWS roles, so the servers that the code runs on basically have access to specific AWS resources. You build, instead of building an IAM user, you build a role. Then when you start up your servers or build out your auto scaling, and you tell it how to build EC2 instances or Lambda instances or whatever it is that your code is running on, you can attach it to that IAM role that has these permissions we talked about earlier. So specific S3 access, specific EC2 access, etc. So again, don't put the keys in your code. But we create that client. We do specify a version and a region. Now, if this is production code and it's relying on some pretty specific features, I highly recommend you lock in the specific API version that you're using, and then in your testing code and your in your unit tests and your production code, and then make sure that when you increment that to a later version as the API version increments, you test the features that you're using. Don't just leave it on latest if you're working on a large project. It's great for a little hobby stuff, but because then you're always taking advantage of the latest version, but it's really not appropriate for larger production projects. So we've created that client, and now at this point the S3 parameter contains an AWS S3 client, and now we can use the put object method on that client to upload a file to S3. And in this example, we're uploading it to a bucket called SGF AWS SDK. The key or file name is called hello.txt, and the key is the entire path to the file. Each object has a key. They let you browse those files as a hierarchy, a lot like you would expect to see in any other file system, but really it's just one long file name. And so that file could be directory1/directory2/hello.txt, and that's the whole key name. And if you were to browse through the buckets, you would drill into directory 1 and then directory 2, and then you would see hello.txt. Then the body of the file is hello world. So we've put that object, and then we're going to get an object from the same bucket with the same key name we specified above. And finally, we're going to output the result, the body key from the result variable that was populated when we performed the get object. Let's take a look at what that looks like. So if we run php index.php, everything that we just talked about is run, and finally at the very end, when it outputs the body of that object, it shows hello world. And if we go back to that code, we can see where that's the original body. So that's exactly what we expected. Let's look, since we skipped over this, let's look a little closer here. Literally, to get this up and running, I created a directory named SDK. I ran composer require, and then AWS/AWS SDK PHP. I created that PHP script we just looked at, ran the PHP script, we were good to go. You'll notice I didn't do anything with credentials here. Since I'm still working in the same shell that I was using for the CLI demo, I still have that profile variable set, and the AWS SDK for PHP is able to pick up those credentials from that profile, which is great. So I have one more example I want to show here. We use a lot of S3 services, and I wanted to highlight something that we've found to be very invaluable when we're working with the S3 services through PHP. And this would hold true through the command line or anything, but we store a ton of text-based data files, and we had concerns about storage, but we didn't want to like put them in big zip bundles or anything and make accessing them difficult. So the compromise was to gzip each individual file. After a lot of testing and reading and trying different things, years ago we'd realized that we could gzip a file, specify the content encoding as gzip, and then upload that object with the gzip encoded body and the gzip content encoding header. And when we pull the object down, either with the SDK or with the CLI or through the web console or even through a public link, we would always get to the original file. We wouldn't get the gzip version. And there's a little bit of magic happening there, but we're chalking it up to the way most HTTP clients will intercept gzip content and automatically extract it. For example, when you go to browse most websites, nowadays almost everything that you're receiving that is compressible is being gzipped, compressed on the server side, sent to you compressed, and then your browser is decompressing it on the fly. So we're using that little sort of HTTP native trick, knowing that the AWS REST API is an HTTP based API, to save a bunch of storage without complicating retrieval. And other benefits to this approach are that if we're using something like AWS Glue to go through a lot of these files and pull data out of them, it's saving on some transfer from reading the smaller files, and it's able to read them just fine. And not only that, we're able to so it ultimately decreases storage space, decreases transfer space. We haven't run into any issues that we can think of that have prevented us from doing this. I mean, this is a simplistic example. I've listed comments by the 3 lines that were added here. The first 2 lines are the most important ones, gzip encoding, and I specify a parameter of 9 to compress the most. In our particular case, these are files we're storing long term. We don't care if it's going to take milliseconds or seconds of extra time up front to compress them, knowing that we're going to save that on the back end in long-term storage. And then we specify the gzip content encoding parameter, which is ultimately a metadata header in S3. And then this is optional, but I thought I'd mention it here because we found this to be very useful. Anytime we're uploading to S3 through the SDK or the CLI, we'll also specify a content type. That way we can tell, even though it's a gzip file, we can tell S3 this is a text plain file, for example, if it's a hello.txt file, or realistically in our case, a text/CSV or an application/PDF or whatever the MIME type might be. So familiarize yourself with MIME types. Try to look up content type for PDF or XLS or PNG or whatever it is you might be uploading. If it's something you think might benefit from gzip encoding and you have a bunch of files, I'd highly suggest you go into a folder, make a copy of a bunch of these files that you're considering uploading as gzip files. Go into that folder locally, tell it to gzip all of them. You could run something like gzip -9 star, and then compare that new folder to the old and see if you're getting a great compression rate. I mean, on these text files, we were seeing upwards of 60 to 90% compression rates, which is amazing. But it's very compressible text. If you're uploading a compressed JPEG, you're not going to see anything like that, so it's not worth it. But something I wanted to throw out here just because it has really decreased our storage needs. The rest of this example is just like before, but this is something that we use day to day, so I thought I'd share as a nice little S3 trick. I'm not going to go into SDK examples with EC2 or CloudFormation. I might throw some of them up in GitHub just so you can see them, but really the only piece that we didn't cover today was looping through feedback that you get from the SDK. But again, that varies by language. They make it nice and easy. In our case, we'll get some list of results like, I don't know, a list of EC2 instances or a list of ECS tasks or whatever it might be. And we can just loop through those with a normal iterator for each or whatever it might be. If you have questions about that, hit me up and I'm glad to refer you to some great reference material. But these resources will hopefully get you started. I listed the official download and reference page for the AWS SDK and tools, the official reference for the AWS SDK for PHP, the version 3 that we're currently using, and then since we focused on those S3 tips, I also listed the put object reference page that lists all of the different parameters you could specify when you're calling the put object method on the S3 client. And then again, another a link to the same GitHub repo that I'll populate with command line code examples and things like that. So with that, I hope that this gave you a good insight into what's possible with the AWS command line tools and the AWS SDK, and hope that you'll dig into these. And if you do have questions, we hope that you join us in the Springfield Devs Discord. Again, look for a link on sgf.dev and find us in the hashtag AWS channel. With that, appreciate your time. Look forward to hearing from you. You can also follow me on Twitter or GitHub. Twitter at JasonK, GitHub at Jason-Klein. And you're welcome to hit me up on Twitter if you have questions as well. Thanks again for attending. Hope you have a great night.